Hi everyone. Today let's look at the LeetCode problem 235, lowest common ancestor of a binary search tree. So we are given a binary search tree and we have to find the lowest common ancestor node of two given nodes in the binary search tree. Okay. Now let's try to understand what does an LCA or the lowest common ancestor mean. It is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants. So basically what this refers to is, for example, assume that I have 4 and maybe let's take 4 and 0. Okay, then 2 is the lowest common ancestor or the lowest common pair ancestor for 0 and 4. And if, for example, if we take 4 and 8, then the common ancestor that the lowest common ancestor that this will have is 6. Okay. Now let's also look at the constraints. It is mentioned that it's mentioned that P and Q will exist in BST. This is very important. So we don't have to take a corner case where the nodes are not present. Okay. So I think the question is clear. Now let's jump into the, try to find the induction here. Okay. Now, if you see here, the idea behind this problem is, so we are going to use this property of binary search tree. So we know that, for example, if we are searching for 2, then we know that it will be in the left subtree because it is less than value of 6. So it will be in the left subtree. Or assume that you are searching for 4, then we would have come here. And then we know that, 4 is less than 6. So we would have come to the left because 4 is less than 6. Then once we reach 2 is less than 4. So we will actually jump to the right subtree and finally reach this node. Now we can use that feature to determine the ancestor here. The idea is that, so now we have to find the first diverging node. When I mean the diverging node, the node in which P and Q shall be in the left and right subtrees respectively. So what it means is both P and Q should be in the different subtree for that particular node. So if you take here, let's take 2 and 8, right? So 2 is in the left and 8 is on the right subtree. So that means 6 is its lowest descendant. Lowest ancestor, my bad. Now, it cannot go above because this is a very basic example. Now let's take another case. Let's take 0 and 4, for example. Okay. In this case, both 0 and 4 are on its left subtrees. So that means it hasn't diverged yet. So we can come to the next node. Okay. It's less than, both 0 and 4 are less, so it will come to its left node. Now we reach 2. So as soon as we reach 2, we find that 0 is it's in left subtree and 4 is it's in right subtree. So that means 2 is our answer and we can just return 2. So, and we can maybe take another example where we have something like 2 and 4. Okay. So this also will be covered like the earlier case. So what will happen is, first it will, both 2 and 4 are on the left subtree, so it will come here. So at this point, if we search, 2 is not less than 2. So, and 4 is greater than 2. So that means it already diverged. So we can actually return this as the its ancestor. So I believe you got the induction to the problem. So there are two ways to solve this. If you the time complexity will be order of n, but the space complexity, if you use a recursive solution, it will be equal to the height of the tree. But if you use an iterative solution, it can be of order of 1. Okay, now let's code this up. First, let's do the recursive solution. Okay, Now let's take the case. So the first case will be if root equal to null pointer, then we'll just return null here, or we can just return root. Okay. Then the other case is if root of so we are guaranteed that we'll find P and Q, so that's one good thing. Ideally this condition will not be hit. We can remove that. If root of val greater than P of val and root of val greater than Q of val, so this means both are on its left subtree. So we can just make it as this will be the case, right? So you can actually now look in its left subtree. Okay. Now if root of val less than, so we'll check this case also, P of val and root of val less than Q of val. Okay, then we can just, so we have to search, both are on its right subtree. Now if this is not the case, then that means this is a diverging node, so we can just return root. Let's just run it and see. Okay, you can submit it. So this looks good. Okay, ideally you can even remove this condition. This condition will not hit because it will automatically come here. Now because given the constraints of the question that you will always have P and Q in the root, sorry, in the tree. Now let's look at the iterative solution. So as you can see here, this will be order of so let's put it here. For the recursive solution, as mentioned earlier, time complexity will be order of n and space complexity will be order of, I would put it as n, but we can put it as height, okay, to be more correct. Now let's take the iterative solution. Okay, now in this case, let's see how this works, right? So we will just go through while router not equal to null period. So what we'll do is if a root of val less than so let's put it this way. So if it is greater than P of val, same way, and root of val greater than Q of val, okay, then we'll just make root equal to root of left, and the else if condition will be the other way around. So here it will be basically less than. So then that means we have to move to the right side of the, we have to set root equal to root of right. Okay, else we can just basically break. It's a diverging node. Okay, so then we can just return a root. Okay, all right, so this looks good. Let's just put the iterative solution also here. So the only difference is that its space complexity will be 1. I believe that this is clear why it is height of the tree for recursive solution, because of the recursive stack and how we go through the tree. Okay, so that's it for today. Thank you.